Welcome to the video for essential idea number 1 in our nuclear chemistry unit. Essential idea number 1 is that radioactive atoms, as you have read a little bit about in your textbook, by definition they spontaneously decompose. And in so doing, a different nucleus is formed. So it has a different element name from the periodic table. And also one or more particles are ejected from the nucleus when it goes through this decomposition. So in first year chemistry, typically the three particles that are studied for radiation are alpha, beta, and gamma. Alpha and beta, as you have read about in your text, are particles of matter. So they are actually, as it says, that they are matter. Gamma is actually a particle of energy, and we didn't do much this year with the idea of the electromagnetic spectrum and light versus X-rays versus microwaves. Gamma rays are a part of the electromagnetic spectrum that are very high frequency and therefore high energy, and therefore more harmful to us if we're exposed to them. And this so-called particle of energy is called a photon. Sometimes gamma is referred to as waves, and sometimes it's referred to as particles. But here, so that we could say that the decomposition force produces one or more particles, we're labeling gamma as a particle of energy called a photon. So the alpha particle is very tangible because what it is it's two protons and two neutrons that are fused together. So in this image right here that you see, let me circle that image. In this particular image right here, it's a good graphic of an alpha particle, two protons, two neutrons, being ejected from a nucleus. As a result of the loss of the two protons, that nucleus will go by a different name because its atomic number has just been reduced by 2. And what you see from a nuclear equation up here is indeed just that. So we're starting with polonium. It has 84 protons, and an alpha particle is ejected from it. An alpha particle consists of two protons and two neutrons. So as a result of the loss of those two protons from the polonium nucleus, it just has 82 protons left. So that means we have to call the atom lead. And the mass number decreases by 4 because in an alpha particle, which is two protons, two neutrons, there's 4. That represents a mass number of 4. And so that's why this drops from 210 to 206. You can see here that the alpha particle has been identified as 4/2 He because two protons and two neutrons together are the nucleus of a helium atom. You also often see just an alpha symbol here as well. So you might see that for an alpha particle. And this last image for alpha particle tells a similar story. So this just reinforces the idea that the alpha particle is two protons and two neutrons combined. And so if we eject that, then as a result of losing those protons, we're going to call the atom by its new element name as a result of the loss of the two protons. Okay, that's alpha. And here at the bottom is just another representation of alpha particle emission from thorium to become a radium atom. And notice in this bottom one, the alpha was written first, and the top one, the alpha was written second. It doesn't really matter. To the beta. Beta tells a somewhat similar story in the way that, again, beta is a particle of matter. But what I like is this part down here, because we should be asking, well, how do you eject an electron from a nucleus? Because a nucleus just has protons and neutrons. And this is fun to understand. What will happen during that nuclear process of the decomposition, a neutron will actually form a proton and an electron. So if you think about it, we've learned that the neutron and the proton are similarly massed, and the electron barely has any mass relative to it. So that makes sense that one neutron could separate into a proton and electron. So we buy it from a mass standpoint. And from a charge standpoint, protons are +1 and electrons are -1. And so if you add a +1 and a -1, you get neutral. So it seems, I mean, it's fascinating to think about, but it seems plausible that a neutron could transform into a proton and electron. The proton remains in the nucleus, but the proton is formed but remains in the nucleus. So that ends up increasing the atomic number by 1, so you still get the new element name. And the beta particle, the electron, is ejected. And here it is in equation form. And you see a carbon-14 atom, so the carbon with atomic number 6. But when a neutron becomes a proton, that adds to the atomic number. So now you've just made a nitrogen atom and ejected the electron. And so, like for the alpha particle, sometimes you see one symbol here. In this case, it's an E for electron. And other times, a beta particle or a beta notation will be written there for beta particle. Gamma. Gamma is, I actually think I'm going to cover this in a separate video. So with the alpha and beta, we're going to call it good for now. Thank you.